Hello. In this lecture we will discuss additional topics which includes message IDs and DPD messages. In IKEv with IKEv version 2, messages are in pair. The pair consists of request-response pair. The request and response have the same message ID. With the first request-response pair, for the IKEv initiation, with a message ID of 0. The IKEv message ID pair is 1 and so on. So, once the session is established, IKEv messages will be sent and received for maintenance of the IKE session. This happens during different scenarios. It happens if a rekey is initiated, when the key lifetime for the phase 2 or child SA key expires. It also happens when there is a notification message sent. Also, if you have dead peer detection configured, at a frequent interval, the two sides send an informational empty message to check the state of the IKE session. So, the message IDs can go up to 4 million message IDs, meaning 4 million message request-response pairs. So, this is highly unlikely that the counter would roll over. For levity, if you have DPD to send a message every 30 seconds, this would result in the tunnel staying up for 4,000 years before the message IDs run out. So, you don't have to worry about that. The key point that I want you to absorb from this discussion is the message IDs are in pairs. So, for DPD messages, the RFC left the timeout and number of DPD messages without a reply that would result in the IKE session deletion. It was left up to the implementation to decide. One key point of configuration that sometimes causes issues is if the DPD messages are set to a very large interval, 1 every hour for example. So, this creates issues with IPsec connections. It mainly creates issues if the head end cannot initiate the connection, which is always the case when the remote peers are dynamic. That is, the remote peers have IP addresses that are changing. In that case, if the head end reboots, the initiator will be sending DPD messages 1 every hour. In the meantime, the remote end will keep sending ASP packets to the responder or the head end, which would be received and ignored, as there is no ASP session with that SPI number. So, it would take up to an hour for the remote side to send another DPD informational message. The informational message comes with an SPI initiator and responder that doesn't have a corresponding entry in the Security Association database of the head end. The head end doesn't have any existing connection to this peer, so it doesn't even send an invalid IKEv SPI notification message. The RFC dictates that invalid SPI notification should be sent only if there is an existing session with that same peer IP address. Only in that case would the head end send an invalid SPI. However, since the head end just rebooted, it would not even respond. So, this is often an issue that pops up especially with dynamic initiators with dynamic IP addresses. In that case, you should configure the DPD to be sent more frequently, typically 1 every 30 seconds or a minute. You can also set the amount of time and number of DPD packets to send, before considering the peer dead and the VPN device would attempt the re-establishment of the connection. You will have to check the implementation specs to determine how this gets configured. Hopefully you enjoyed this lecture. We will discuss more in the next lecture.